Hello, welcome to another discussion in general mathematics, which is the introduction to exponential function. For our learning objectives, we have represent real-life situations using exponential functions and distinguishes between exponential function, exponential equation, and exponential inequality. Usually, the term exponential is often associated with any phenomenon characterized by rapid growth with alarming consequences. Example of which is the spread of virus or bacteria. How fast a virus or bacteria spreads is an example of exponential phenomena. Another example is the exponential decay. One example is the depreciation in value of cars, appliances, gadgets, computers, and the likes. Another example is the radioactive material. Nuclear engineers use the exponential decay formula to determine how long nuclear waste must be stored before the amount of radioactivity is negligible, the example of which is plutonium, radium, and other nuclear waste. If we have the exponential decay, which is a decreasing function, we also have the exponential growth, or those that increase in value exponentially, as shown in the graph. So here we have the new confirmed cases of COVID-19. This is the graph. And we also have here the graph of bank balance that increase exponentially. Other examples are the increase in value of gold and land. And also we have, if you do chain letters, text brigade, or the networking business. Another example is the use of compound interest in banking and finance. Now that you know examples of exponential phenomena, let us now distinguish the difference between exponential function, exponential equation, and exponential inequality. But let us define what an exponential expression is. It is an expression of the form a times b raised to x minus c plus d, where b is greater than 0 and b should not be equal to 1. So b here is your base. Okay? It is a number greater than 0 but not equal to 1. And your x minus c here is an expression, or it is the exponent that contains a variable. This time, let us define an exponential function. It is a function defined by f of x is equal to b raised to x, or y is equal to b raised to x. Again, your b should be greater than 0 but not equal to 1. And your b again is the base, and x is your exponent, or the variable, your exponent that contains a variable. Okay, to fully understand the definition of exponential function, let's have some examples. Determine whether the given function represented by its equation is an exponential function or not. Number 1, f of x is equal to 2.5 raised to 6x. So here, your base is 2.5, so this is greater than 0, and your exponent is 6x. So since it contains the variable x, so this one is an exponential function. Number 2, you have g of x is equal to x raised to 3. So here your base is x and your exponent is 3. And x is not a number greater than 0. It is a variable. So therefore, this is not an exponential function. Okay, number 3, you have y is equal to 0.5 raised to 3 minus x. So again, your base here is 0.5. 0.5 is still greater than 0. And you have the exponent that contains the variable x, which is 3 minus x. So again, number 3 is an exponential function. Number 4, you have h of x is equal to negative the quantity of negative 4 raised to n. So here your base is negative 4. And your variable is the exponent n. But since your base is less than 0, okay, we know that your base should be greater than 0 but not equal to 1. And negative 4 is less than 0. So this one is not an exponential function. Number 5, y is equal to negative 3 raised to a plus 1. Okay, so your base here is negative 3. Actually, your base here is simply 3. Okay, and your exponent contains the variable a, which is a plus 1. So here, your 3 is not enclosed in a parenthesis. Okay, meaning the base is simply 3, and the negative here indicates that your function is a decreasing function. So 3 is greater than 0. You have here the exponent a plus 1. It contains the variable a, and the negative indicates a decreasing function. So therefore, this is an exponential function. So there is a difference when you enclose a negative number in a parenthesis and when you do not enclose it. Okay, this time let us define an exponential equation. It is an equation involving exponential expressions, or it is an equation that contains a variable in the exponent. So example is this one. So you have here the base greater than 0, and you have the variable x squared. You can have it only on one side or both sides. Okay, so we also have this one. So here you only have the variable on the left side. So this one is also an example of exponential equation. And the last one, 2 raised to 2x minus 1 is equal to 4 raised to 3x plus 2, is also an example of exponential equation. So it contains the equal sign. You have here the base. The bases are greater than 0. And your exponent should contain the variables. Any variables other than x. Okay? And lastly, we have exponential inequality. It is an inequality in one variable having a variable in the exponent. So one variable only. So we have 3 raised to x plus 1 is greater than 243. Again, your bases are greater than 0 but not equal to 1, and you have the variable in the exponent. So these are other examples of exponential inequality. Okay, so there you go. I hope you see the difference between exponential function, exponential inequality, and exponential equation. For your output in this topic, you're going to determine whether the given is an exponential function, equation, an inequality, or none of these. So you have here 10 items. Okay, that ends our discussion for today. Again, visit your Google Classroom for your output, and then kindly subscribe, like, comment, and share. Thank you. And God bless you all.